So let us talk about how do we use the first derivative to find out the relative max or local mean. Relative means local, right? Local max or local mean. That's what we are going to do next. Now you see that, look at this one. The function is increasing here and then decreasing, right? If there is a combination of increasing and decreasing, then you see that there is a local max. If there is a combination of decreasing and then increasing, right? You can say like f prime is positive, f prime is negative. If there is a combination of first positive and then negative, then there is a local max. If there is f prime negative, it is decreasing. F prime positive, increasing. If there is a combination of negative and positive f prime, then there is a local mean. Look at this here. Everything is increasing everywhere, right? On the left of C, it is f prime is positive, f prime positive, f prime positive. So there is no local mix or local mean or local max. And here f prime negative, f prime negative, right? So in this case also there is no local max or local mean. So what you can see here is if the f prime changes sign from positive to negative, if f prime changes sign from positive to negative, then the function has local max. Okay, if f prime changes sign from negative to positive, then f has local max, local mean. Okay, so in these both cases, no local max or mean at x equals to c. So at x equals to c, at x equals to c, at x equals to c. This is what this the use says. Okay, let's look at this one. Let fx is continuous in an open interval containing c. If f prime of x changes sign, if the derivative of x changes sign from negative to positive, to at c, then f has local mean at x equals to c. If f prime of x changes sign from positive to negative, and then negative, at x equals to c, then f has local max at x equals to c. That's the first case. Okay, this is figure B, this is figure A. These are figure C and D. It is like A, B, C, D. If f prime of x, if the derivative of f have same sign on both sides, on the left side and right side, both sides of c, then fx has neither local max nor local mean at x equals to c. This is what we get. Okay, so let us do an example on how to use that concept. Let fx equals to 8 minus x times x plus 1 square. Okay, find critical numbers. How do I find the critical numbers? You find out the derivative and set that equals to 0, and or find out where the first derivative is not defined. How do I find out the derivative here? It is like f times g, right? How do you find the derivative of the product? It is f prime equals to, derivative of f is negative 1 times g is x plus 1 square, right? And then plus f is 8 minus x times the derivative of g. How do I find out? It is like u square, right? It's like, you can think this is like u and then 2. So it will be 2u, 2 minus 1 times u prime is 1. So basically you get negative x plus 1 square plus 8 minus x times, oh, let me write on 2 at the front. 2 8 minus x times x plus 1. This is what I got. Okay, now what you do is you need to simplify that one. Okay, if you simplify, what do you get? Basically you will get, if you simplify, you will get this. Can you factor out x plus 1 from both? Let me factor out that x plus 1. I took that x plus 1 out. What is left is negative x plus 1 and then plus 2 8 minus x. You see that? Let me simplify inside the parenthesis. X plus 1 is there, and there is a negative x minus 1 minus plus 16 minus 2x. You see that? So what do you get? You get x plus 1, right? And then negative x minus 2x is negative 3x. And then there is plus 15, right? Since there is no x in the denominator, or there is no no root, so the domain is all real numbers, right? So you can pick any, so you don't have to worry about where f is not defined. F prime is defined everywhere. F prime is defined everywhere, okay? So for the critical numbers, what you do, f prime equals to 0. This implies x plus 1 equals to 0. That is x equals to negative 1. This is one critical number, right? And then negative 3x plus 15 equals to 0. That is, what do you get? Negative 3x. Negative 3x equals to negative 15. I subtracted 15 from both sides. Now divide by negative 3. You will get x equals to 5. So the critical numbers are x equals to 5 and negative 1. These are the critical numbers, okay? So I want to find out where it is increasing and decreasing. For that, what we need to do is we need to draw a line, right? And mark those critical numbers. So how do I mark those? Is negative 1 is somewhere here. You see that? And then 5 is somewhere here. Now I want to pick the test points. So I want to pick a test point somewhere here, another test point here, another test point here. Let me pick negative 2 as a test point, and I will plug in the f prime. What is f prime? F prime is x plus 1 times negative 3x plus 15. F prime equals to x plus 1 times negative 3x plus 15, okay? And then I want to pick a test point here as 0, test point here as 6. Okay, let's plug in negative 2. What do you get? If you plug in negative 2 here, negative 2 plus 1 is negative 1, right? Times negative 3 times negative 2 is positive 6 plus 15 is 21 times negative 1. That's what you will get. So it will be negative. When you use negative 2, you will get negative sign. So it is decreasing here, right? It is decreasing here. Let's plug in 0. 0 plus 1 is 1, right? Negative 3 times 0 is 0 plus 15. So plus 1 times plus 15 is positive. So it is plus, 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 plus. You see that? And then here at 6, let's plug in 6. 6 plus 1 is 7 times. 6 times negative 3 is negative 18 plus 15 is negative 3 here. You'll get negative in the second times positive in the first. So it is negative. So what do you think about increasing and decreasing pattern here? I see this is decreasing, this is increasing, and this is decreasing in these pieces, right? So you can denote like that. So you can say that increasing in the interval, negative 1 through 5, right? And then decreasing in the two intervals. What are the intervals? Negative infinity to negative 1. Left of negative 1, it is negative, negative, negative. So it is decreasing. And another interval is 5 through positive infinity. That is also decreasing interval. So tell me, how about the local max and local mean? Local max. Does it have local max? Yes. You see that? It is increasing. It is a combination of increasing and decreasing. So local max at x equals to 5, right? And how about the local mean? Local mean at x equals to negative 1. You see that? It is decreasing and then increasing. Combination of decreasing and increasing. Or you can say that f prime is changing sign from negative to positive at negative 1 and from positive to negative at 5. So that's why they have the local max and local mean. But if you want to find out the local max value and local mean value, how do I do that? I would write this way, okay? Value. To find out the value, plug in that 5 in the original question. Okay, what do you get? Let's plug in 5 here. 8 minus positive 5 is, 8 minus 5 is 3 times 5 plus 1 square is 6 square. 36 times 3 is 108, right? It will be 108. Okay, so if you want to write in a point form, it will be like 5 comma 108. You can write that way. You understand? Let's plug in -1. If I plug in -1 here in the original function, if you want to find the value, it is asking the height. Okay, so you need to plug into the original function. So 8 times -1 is 8. Sorry, 8 minus -1 will be 8 plus 1. That is 9 times. -1 plus 1 is 0. So 9 times 0 is 0. So value is y value basically equals to 0. So what is the point? -1 comma 0. If the point is asked, you can write that way. Okay. So I will do one more example. Okay, guys.